So, in the last lesson, I have asked you to do question 1 to 16 and question 20 to 22. Now let's check the answer. Okay, question 1, the answer is x is 4.04. So remember to take 3 significant figures if necessary, okay? 3 significant figures. Okay, question 2 is 3.97. 3.97. Question 3 is 6.30. 6.30. Question 4. Theta is 58.8 degrees. Question 5. Theta is 125 degrees. Question 6. Theta is 30.2 degrees. Question 7. Theta is a right angle, 90 degrees. Okay. So you can check yourself. I don't read it. Okay, question 8. Question 9. Question 10. And then question 11 to 14. Okay, 11, no. 12, yes. Angle B is 90 degrees. 13, no. 14, A, 60 degrees. Part B is root 6 over 3. Root 6 over 3. Question 15, the ratio is 1 to root 3 to 2. Question 16, part A. WY is 8 cm. WZ is 6.56 cm. Okay, here is the answer for question 20 to 22. So after checking the question, the answer of the question, we go to section 3. We'll talk about sine formula and cosine formula. So the first example, look at this figure. This is a trapezium. Therefore, AB is parallel to DC. Okay, AB is 9 cm, BC is 8 cm, and this is 130 degrees, this is 28 degrees. Find the length of AD, part A. And part B, find the length of DC. Correct to 1 dp for all the answers. So, the first question, part A, asks you to find the length of AD. We have 4 information and a pair of parallel lines. How to find the length of this? So we can draw one more parallel line, which is parallel to AD on here. Okay, so I have drawn a parallel line which is parallel to AD. Therefore, the length of CE is just the length of AD. So if we can find the length of CE, we can find the answer of part A. However, in this triangle, and I let this point to be E. However, on this triangle, do we have enough information to find this line? So these two lines are parallel. Can we get this angle? Yes, this angle is the same as this angle. And so we'll get this. We can write first ACE such that DA is parallel to CE. And then we will get this information. Angle CEB is just angle DAB because corresponding angles DA parallel to CE. So we now focus on this triangle. So can we find EC? Yes, we look at this. This is X, this is 130 degrees. They are parallel, the sine and the corresponding angle. So if we get this angle, we can find this line by using sine formula. Write down the sine we want to find first. C, this one must be CE, which is CBE. CE correspond to this angle, CBE. Get it? Okay, the side, the known side is BC. So BC side angle BC must match. BC. Okay, BC corresponding angle is B angle BEC. Okay, CE, we don't know. Angle CBE, side turn 8 degrees. BC, 8 cm. Side angle BEC, 130 degrees. Therefore, CE is 8 sine 38 degrees over sine 130 degrees. After calculation, we have 4.9 cm, correct, to 1 dp, and which is equal to what we are asked to find, AD. This is part A. So in part A, we can find the length of AD as 4.9 cm, correct to 1 decimal place. And we can write down the reference why AD is equal to CE. So this is a parallelogram. AECD is a parallelogram. So the opposite sides of parallelograms are equal. So we can write opposite sides of parallelogram. Okay, we go to part B. Part B asks the length of CD. Okay, the length of CD actually is just the length of AE. If we can find AE, we can find DC. Okay, AE is a part of AB. Therefore, if we can find the length of BE, we can find the length of AE. So we can find the length of DC. Okay. So again, on this triangle, we can find other lengths. And so we can find BE. Okay. So What we want to find is to find BE. So again, x, the parallel of x is 130 degrees. So the parallel of BE is this angle, which we can calculate by angle sum of triangle. Therefore, we can find angle BCE now. In triangle BCE, angle BCE is equal to 180 degrees minus angle B and angle E, and it is CBE and CEB, angle sum of triangle. So 180 degrees minus 130 degrees minus 38 degrees, the answer is 32 degrees. So this angle is 32 degrees. We can use sine rule to solve BE. By sine formula or sine rule. Okay, what we want to find, write it first. BE sine angle B1E equal to, and we can use CB sine angle CB. So this one in triangle BCE, so there is a C missing, and BCE, so E missing. Okay, sine angle C we have just found, which is 32 degrees. BC x, parallel of x 130 degrees. So BE is just x times sine 32 degrees divided by sine 130 degrees. Okay, so this is BE. We can write CM. Actually, we don't have to calculate this value. We can just keep this expression. We are now going to find AE, and then we can get CD. So we can calculate AE, which is just 9 minus BE. So actually it is CD. CD is AE. Again, opposite sides of parallelogram. Okay, AE is AB minus BE. So 9 cm minus this one. Okay, so after calculation, we can get 5.1 cm, correct to 1 dp. So now you can try this question instant drill. So after you have finished, you can check the answer. 4.9 cm. And you can try these two questions. In the figure, ABC is a straight line. DA is 9 cm. BD and CD is 6 cm. And angle BAD is 30 degrees. Okay, so you need to find the angle BDC. Second, you need to find the length of BC. Okay, second question. This is a trapezium. So according to this information, find the length of AD and DC. So I will give you the answer on next section. Okay, now we'll learn the cosine formula. Okay, again, triangle ABC. This is ABC. Okay, the first rule is c squared equals to a squared plus b squared minus 2ab cosine c. The second rule is cosine c, which is equal to a squared plus b squared minus c squared over 2ab. Actually, they are the same. But when we use this formula, we can easily find the sine of c. When we use this formula, we can easily find the angle c. So, although they are the same, we can still memorize these two formula. Now I will prove this cosine formula to you. So again, triangle ABC. So this is A, this is B, this is C. Again, we draw the altitude from A to BC, just like the proof of sine formula. So again, we need to find cosine C. Okay, we want to find cosine C. If we want to write down cosine C, we need to have hypotenuse and what? The adjacent side. However, this length is A, so we need to define the length of this first. We assume this is x, then this is A minus x. So cosine C is x over b. Okay. The next information is we want to use 2 times the Pythagoras theorem to write down the relationship on this triangle and this triangle. So in triangle ABD, so c squared equals to h squared plus a minus x squared. In triangle ADC, b squared is h squared plus x squared. So what are they in common? Which is x squared. So we can express x squared. So this is c squared minus a minus x squared. H squared is b squared minus x squared. So they must be the same. So c squared minus a minus x squared equals to b squared minus x squared. So we can expand c squared minus x squared, a squared minus 2x ax plus x squared equals to b squared minus x squared. C squared minus x squared plus 2ax minus x squared equals to b squared minus x squared, on which minus x squared is the same, so we can cancel. So c squared minus a squared plus 2ax equals to b squared. It's almost come to the formula. So we use c squared as the subject. C squared equals to a squared plus b squared minus 2ax. So we stop here. Look at the formula we get at the very beginning, which is cosine c equals to x over b. Cosine c equals to x over b. So x is b cosine c, isn't it? So substitute on here. So c squared equals to a squared plus b squared minus 2a. X is b cosine c, which is the same as the formula here. So this is the first formula. When we make cosine c as the subject, okay, so for example, it is 2ab. We put it on the left hand side and put all of this on the right hand side. So a squared plus b squared minus c squared. So when we want to use cosine c as a subject, which is a squared plus b squared minus c squared, the right hand side over 2ab. So this is the second formula you need to memorize. So how to use this formula, the first cosine formula? When we use this formula, we want to find the value of sine c. So we need to first have the value of all these variables, which is sine A, sine B, and angle C. So on a triangle ABC, sine A is here, sine B is here, cosine C is here. So this is SAS. So when we have a sine and then an angle and a sine, that means two adjacent sides with the included angle, we can use cosine formula to find this side. Okay? So how about the second formula? Cosine c equals to a squared plus b squared minus c squared over 2ab. So on the left hand side, we can find angle c. We want to calculate the angle c. So we need to have these three lines on the right hand side. That is ABC. So that means in a triangle ABC, we need to have all the sides, which means SSS. So if we have all the sides of a triangle, we can find any angle. This is angle C. So actually any angle. So we can exchange the size, so we can get any angle. Okay, so if we have all the sides, we can get any angle. If we have two sides and include angle, we can find the opposite side of the included angle. Okay, so in the next section we will discuss how to use these two formulae to solve the triangles.